I'm Tim Miser, Associate Editor for Power Engineering Magazine, and I just got out of a session entitled Novel Clean Coal Applications in a Carbon-Constrained Market. I'm here with the session chair, Dr. Joseph Smith, and Joseph has been kind enough to take some time to answer a few of our questions. Joseph, thanks for meeting with us.
You're welcome. It's good to be here with you.
Joseph, what is the future of coal-fired generation in the wake of the Clean Power Plan?
Thank you for that question. It's a very important question. Coal is our most abundant energy source in the United States and in the world, and it will be part of our energy mix going forward. Clean coal is a necessity to address some of the issues that we face that were discussed just last week in Paris. Global warming and climate change are serious issues. And so coal has come under attack as one of the main contributors to that. So the session that we just got out of is focused on finding ways to address both climate change and global warming and carbon emissions through new technology. And so that's really what we're good at here in this country, and that's what we're talking about today.
So Joseph, talk to me a little bit about the coal combustion rule. How will that recent development affect coal-fired generation?
So again, the regulation drives technology. As you look back over history, the Clean Air Act, for example, the Clean Water Act, those all caused evolution in the technology. And so the Clean Coal Act, same thing. We'll see more new technology. Currently, one of the challenges we have in our power generation in the U.S. is we have an aging fleet. And so a lot of the coal generation capacity that's being retired now are very old. And so that gives us a great opportunity to implement some of this new technology. So again, regulation, I mean, government has its role, and regulation helps to drive technology and utilization of new technology. And so I think it's a real positive thing.
So, I'm sort of comparing the market, the political climate for coal-fired power generation domestically in the United States compared to the broader markets worldwide. What is the difference in attitude? We see lots of coal plants, big plants being built in other locales. Talk to me a little bit about that.
Okay, you bet. And it's very interesting. We do a lot of work around the world. I just got back from Shanghai, China, and a conference there in Shanghai looking at, again, energy, and most of the research that's going on right now in China is focused on coal because that's their dominant fuel, that's what they have. And so what you'll see, again, going forward is China will continue to use coal, they'll continue to use more nuclear, they'll continue to use more renewable energy because they have such an insatiable desire or demand for energy. In the U.S., we have more of a developed market, and so we don't see a large increase in generation demand, but we see, again, regulation-driven modification of the technology. And so what I see happening as we go forward is you'll see more of that implemented. Coal has come under attack in the U.S., and so there's a reason that has happened. We need to focus on renewable energy, and we have. The U.S. government has invested significant in developing new renewable energy, and I completely support that. But I do believe, if you look at all the projections, and I believe the projections are actually pretty correct, that coal and gas, fossil energy will remain part of our energy portfolio going forward. What will happen is we'll do it better, we'll do it cleaner.
So Joseph, what kind of benefits can be realized by hybridizing coal into a portfolio that also includes nuclear and gas and renewables? I guess what I'm asking is, what does coal offer in this modern age?
Yeah. Well, again, coal is a plentiful resource that our country has. We need to use all of the above. I think President Obama coined that phrase, and I think it's very apt. There are lots of different sources, and so coal will be part of our energy mix. Now, the concept of hybridization that you mentioned is really an evolving concept, because in the past, we've built a coal plant that's generated 500 megawatts of electricity. We've built a gas plant, and they may be even co-located, and they may provide electric power to the grid. But what you'll see in true hybridization is polygeneration. And so you'll see generating electricity, you'll see generating liquid fuels. And can you imagine a coal plant that also generates liquid fuels, right? Or chemicals. And so you see that starting to happen right now when you bring wind onto the existing grid. That causes a lot of instability with the grid because wind is intermittent. But with better control technology and closer hybridization, with good energy storage, you can hybridize and you can get better efficiency. So instead of 35, 40% efficient, you can get higher efficiencies. You can do it cheaper, and so you get better economics, and you can do it cleaner. And so again, the climate impact is reduced. And so hybridization offers a lot of advantages going forward, and coal will be part of that.
So what role does carbon capture and sequestration play in mitigating some of coal's downsides?
Yeah, absolutely. Coal is, as I said earlier, is one of the main contributors to the carbon emissions that we know of in our country that are man-made. And so carbon capture, that means new technology. If you take an old power plant, it's relatively hard and expensive to separate the carbon dioxide from the effluent that comes from the combustion chamber. New designs, we just heard in our session about work that's going on in Italy right now that is a pressurized, flameless combustion process that they can capture 99% of all the carbon dioxide, and then they can either inject it into the ground as enhanced oil recovery, and for every ton of CO2 you inject into the ground, oil companies have shown they can get 3 to 4 barrels of oil out of the ground. And so again, that affects the economy, right? The economics of that carbon capture and sequestration. There are other technologies that utilize that carbon dioxide as well.
So, Joseph, I don't think I have to tell you that coal does receive its share of bad press, and it seems that renewable sources, solar, wind, get a lot of great press. I wonder, though, and I've talked to other people, if you take into consideration the entire product cycle, that a lot of those renewable hardware technologies are themselves carbon intensive in manufacturing, that energy storage is itself a carbon intensive manufacturing process. How do renewables then stack up in the final equation against coal?
Yeah. It's application specific. I would tell you there's a technology that we use to evaluate hybridization concepts, and they're based on full life cycle analysis. And so you look at the entire cradle to grave or cradle to pump cycle for whether it's coal or oil or natural gas or wind or solar, energy storage, nuclear. All of those have a carbon footprint. All of those have water demands, so they use water. And so when we talk about, whether renewable energy is cleaner than coal or natural gas or fossil fuels in general, it's not as simple as saying, well, when you burn coal, you make a lot of CO2, and when you use solar, you don't have any CO2. Because it is a full life cycle that you have to consider. And those technologies are being used. Sustainability, environmental sustainability is something that we have in the engineering area focused, just like we focused on safety in the 70s and 80s. And so that has come to the forefront. So when we design, when we evaluate new technology, sustainability with full life cycle analysis is part of the answer.
Well, hey, Joseph, thanks for taking a few minutes with us to educate us. It's been very valuable, and I hope that everybody that gets to see this will feel like they've learned a little something. Another successful session here at Power Generation Week 2015. Once again, I'm Tim Miser, Associate Editor for Power Engineering Magazine.